Welcome to EDU World Space.
Alright, so here is the problem 23.40. Consider the following three complexes and answer the question A, B, C, and D. Part A is asking you which of these three complexes can have geometric isomers. So the arrangement of similar groups in complex can be either adjacent or opposite to each other. And this type of arrangement will give geometric isomers. And the presence of similar groups on the same side is called the cis isomer, whereas the similar groups presenting the opposite to each other is called the trans isomer. So among the three complexes in this question, only the complex 2 can have geometric isomers, and it will show facial and meridional isomers. And I'll draw the two structures right here. NH3, CO, Cl, 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 NH3, NH3. And the isomer will be Cl, CO, Cl, NH3, NH3, Cl, NH3. So comparing these two, this is a facial isomer, and the other one is meridional isomer. So only the complex 2 will have geometric isomers. Now let's look at question B. Question B is asking which of the complex can have linkage isomers. So some ligands molecule contains two different atoms, and such both of the atoms are capable of donating electron pairs to the metal atom. So therefore, they can link to the metal through either of the atom. And this type of linkage will give linkage isomers. So an example of the donating atoms could be sulfur, nitrogen, oxygen, etc. So among the given complex, only the complex 1, and this complex is CONH3 5SCN 2+. Only this complex can have linkage isomer because it contains the ligand S, C, N, and the two atoms sulfur and nitrogen can donate an electron pair to the metal. So this complex can have the linkage isomer, and I will draw the two structures right here. NH3, CO, NH3, 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 SCN, whereas the isomer will be CO, NH3, 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 and NCS. So this is a linkage through sulfur, and this is a linkage through nitrogen atom. So these two complexes are called the linkage isomers. Part C, we have which of the three complexes can have optical isomers. Or so complex compounds which do not contain any elements of symmetry And this is said to be optical active. So the complex compound whose mirror image are non-superimposable and this is called optical active. So looking at the three complexes given in this question, none of them will give complex can show optical isomers. So the answer for part C will be none. Part D, coordination sphere isomer. Alright, so among the three complexes which have coordination sphere isomers. So complex compound in which the ligand will present inside the coordination sphere can be interchanged with those present outside the sphere, and that can have coordination sphere isomers. So the ligand inside the coordination sphere can have interchange with those present outside the sphere. So among the options given in this question, the complex number 3, COClBr5NH3, this can have coordination isomer. This is because it contains 2 halide ions and 5 ammonium molecules. So it can form coordination sphere isomers as this one. So for example, CONH3 5BrCl or CONH3 5ClBr. Or even they can have this complex formula, CONH3 4ClBr NH3, etc. So this complex can have coordination sphere isomer.